Okay, let's look at example 2, which is where I'll stop once I finish this. In example 2, the acceleration of a car is known to be negative 2t plus 5. So this is not a constant acceleration now, it's varying linearly. And in fact, the acceleration is starting at 5, for t equals 0, and decreasing by 2, and eventually becoming negative over time, and then starting to head back. It's in kilometers per hour squared. Determine the time it will take for the car to become stationary and how far it travels if initially the car was traveling at 60 kilometers per hour. Okay, so we need to first determine what information we have. We know that acceleration equals negative 2t plus 5. We also know that v0 is equal to 60 because that's given here, and there's our acceleration. Now, there's not a lot of other obvious information here, but the question says determine the time it will take for the car to become stationary. So when the car becomes stationary, that's when the car has stopped moving, which means we want to know how long does it take to get from v0 60 to vt equals 0. It'd be easy to get tricked into the question here where, and I might be wrong, but I suspect at the moment we don't actually have to find a displacement model. We only need a velocity model. We just need to find the time when velocity is 0. And remember, we've already determined, we've ascertained just through a bit of logical thinking that acceleration model, which graphically looks like this, so it's negative 2 plus 5, plus 5's there, but it's decreasing. So the acceleration is decreasing. That means initially the car is going at 60 kilometers an hour, but increasing in speed because it's got a positive 5 acceleration. So the velocity is going to be going up, but then the velocity is going to be going down. And so this thing will be stationary when the velocity is 0. And that's that point there. That's what we're looking for. So let's do it. The acceleration is that. Then we integrate acceleration with respect to t to get the integral of negative 2t plus 5 with respect to t, which is equal to negative t squared plus 5t plus some constant, and that's our velocity. Now, we also know that v0 is 60, so at t equals 0, v equals 60, so we get 60 is equal to negative 0 squared plus 5 times 0 plus c, so therefore c is equal to 60, and now we have velocity is equal to negative t squared plus 5t plus 60, and we want to know when is the velocity 0. So therefore we're trying to solve negative t squared plus 5t plus 60 equals 0. And we can multiply through by negative 1 to get t squared minus 5t minus 60 equals 0. And now we need to solve that. So the first thing I'm going to do is see if I can factorise it. And I'll get 6 times 10 is pretty close to having a difference of 5, but not quite. 5 times 12, it's got a difference of 7. So not quite again. So I suspect I can't factorise it, which means I'm going to go instead to my quadratic formula. T is equal to, and I could go to completing a square if I want, and you might be lucky enough and be able to solve it in your calculator depending on what the question asks, but I'm going to do it this way. I get negative 5 plus or minus square root of negative 5 squared minus 4 times 1 times negative 60, and of course that is divided by 2 times a, which is 2 times 1, and that gives me 5 over 2, which is 2.5, plus or minus the square root of 25, that, minus 4 times 1 times negative 60, which is plus 240. No, plus 320, my apologies. No, 240 is right. Don't know what's going on there. And so that's equal to 265, the square root of 265 over 2. And I can see this is going to be totally irrational. The square root of 265 is going to be more than 15, which means that 5 over 2 is going to be less than the 15 over 2, give or take. So I need a positive time. I'm expecting the 5/2 minus is not going to give me the type of time I'm looking for. And so that gives us 10.639 times measured in hours. So this goes slowing down quite slow and a little bit unrealistically, or negative 5.639 hours, which is unreasonable because we're not dealing with negative times in this case, we're dealing with positive times. So doesn't make sense. It's not an overly realistic situation, but of course we're starting at 60 kilometers per hour and it's accelerating. Remember, our time is in hours at negative 2t plus 5. So it starts accelerating at 5 kilometers per hour, and then after an hour it's accelerating at 3 kilometers per hour. So it is changing quite slowly. So this car is on the road for 10.64 hours straight. So it's a little bit unrealistic in that sense, but let's move forward, shall we? So the second thing we need to realise is that the question asks us for how far the car travels in this time. So now we do need to calculate x, and keep in mind x is the integral of v dt. So in this case x is the integral of negative t squared plus 5t plus 60 dt, which is equal to negative 1/3 t cubed plus 5/2t plus 60 t plus c2 this time. We also know that at t equals 0, x is 0. We're going to define, that's where it starts. And we get negative 1/3. Well, actually, I don't have to worry too much about that. If I put 0 in here, I get 0, 0, 0. So c2 will be equal to 0. And that gives me x is equal to negative 1/3 t cubed plus 5/2t squared, that should have a squared on it, plus 60t with nothing on the end. And I want to know what is x equal at 10.639 hours. So I've put that in my calculator and I get x is equal to 519.9, and this is kilometers. So again, we go back to that unrealism in the answer. If you're traveling for 10.639 hours at 60 kilometers an hour, you'll get to about 64 or 640 kilometers. We've got 519, but this is slowing down over time. It speeds up at first and then slows down over time. So, you know, we're pretty happy with that. So there's my displacement and my time, and it gives us that overall distance, in this case the overall distance traveled, and it gives us the time when the car becomes stationary. So that's a look at kinematics. Hopefully the questions that you do will be slightly more realistic than the question I've just done, but otherwise hopefully it was fun and you'll get some enjoyment out of it and you'll be able to do it and get that satisfaction. Here's the learning goals and success criteria for you to have a look at, and all the best.